Well, it's literally Microsoft Office. I think we'll learn Microsoft Office.
Yeah, it'd be very interesting.
Anything else we don't care about.
All right, good morning. It's 10, so
Well,
we'll try to stick to our schedule today. We've got a couple of people who are coming in online, so we'll make sure they get on. One of the things I can do is let me pull up the schedule so you can see what that looks like.
But apparently they're changing that yet again.
Yep.
Well, that's a separate effort, but yeah. Perspective of investment is so much lower. This is innovation, so therefore they had to come up with that disguise.
Oh, that's the file.
But it's a very good one.
It's already responsive, right? But
Yes.
now you have to set up
But my hope is to get the Raspberry Pi connected through the speed server so the kids can access it.
edit
By using this programming device.
yeah, where you have all the Apache countries, like what have modules it should load and where the
All right, so it's 10 o'clock. We've got the Hangout running. So that laptop there's got it's focused the room, so it's up and running. And I've got my laptop plugged in as well. So the first session we have is offline micro digital library, and this was going to be run by Ian Craig, one of my students who worked on this with Inveneo. He got stuck at work. Somebody called in sick, so he has to be there. So while I was the advisor, so I should know a few things about this. So I figured I'll run through some of the slides and then we'll do maybe a 5 to 7 minute introduction about what this thing is. He has other results which are online, so we can always take a look at that. But then maybe at that point we can switch over and jump into the discussion part of what needs to get done and what else remains. So we've got that at 11:15. We have Jennifer Martino coming in from OPC Canada. So that comes in Google Hangout. She's remote. Then we'll break for lunch, and then we've got. Sorry, wrong laptop. There we go. So after lunch, we've got George Hunt. So George is going to talk about this new project about SD cards and how they can be added to existing expos. We'll also have that streaming over Hangout so people can watch it remotely. We have Rangan from Australia at 3:15. He's going to talk about their new project, the One Education Infinity device, and of course what they did with 50,000 exos in Australia. And then we've got a session after that on content creation, especially this problem of having multiple sources and how do you pull them in and formats and so on. That in fact, this morning we've had some conversations about that. So that's our schedule in a nutshell for today. Let's deal with the first half, and then when we break for lunch, we can talk a little bit more about the other one. All right, so what I will do is, let's see. Yeah. So these are some slides that he put together for a presentation he did for OPCSF a couple of months ago. And so I'll just go through maybe the first few to give you an overview of what this is, and then we can jump into this. Okay, let's see. Does this work? Okay. That would be easier for me to run this from. Never mind. I'll just do this. So this was a project that came out of Inveneo. They had a request for this. The idea was that they have a bunch of these solutions coming in from different places. So World Possible has a Rachel. Inveneo is looking at some other devices. Intel has something. We've of course been working with XS and XSCE. So lots of different things, and you've got the software configuration, the hardware, And so the idea was, if you look at about 5, 6 of these things, can we compare them across the board and come up with some kind of an understanding of, how many clients before this thing falls apart. That's sort of a baseline. So in most of it, I asked them to stick with whatever they received from the vendor or the provider as in terms of, out of the box and not tweak it.
The full config.
Right. So when Rachel came in, they basically got a box that was from Word Possible and stuff like that, just to get a baseline, and then they could move to other tweaks. So that's kind of what they did. And then this was an internship, so once it was done, they put the stuff together, and I believe Inveneo is going to publish this thing at some point. So Rachel, Library Box, Intel Education, these were the 3 that they ended up testing, because these were the ones they got from the vendors as, out of the box, let's just say. There are other solutions, and my understanding was that they actually ended up spending a lot of time just dealing with these vendors and online sites and so on, just to get information. So for instance, I think one of these, Outernet, the one that has a satellite connection and supposed to bring in the stuff, it was just like talk, and they were never able to actually get the device. I think they recently did get it, but it was very difficult to get any information. And for some of the other ones, it was, again, like, look at our PDF on the site, and that's pretty much it. So that was a big challenge. After they got the devices, so let me back up a little bit. So initially, when this project came along, one of the things we did was, so I don't know, some of you may remember from maybe 3 years ago, I had a student who did a very extensive load testing type study on the XS 0.7.
Yeah, that was the last version.
That was Ben, yeah. Ben. So Ben did this as part of his master's thesis. Ben used to work at YouTube. He did this for a living, so he sort of knew the mechanics of it. And then we went through a whole spectrum of devices, and you can find in fact, his thesis is up on the wiki. But from what I recall, on one end of the spectrum, the weakest of the devices was the XO1 with an SD card acting as a server, and on the other end was a Xeon with 4 cores, big humming machine. And the idea was, again, let's see at what point do these break. I remember XS 0.7, unlike Rachel, actually had a full Moodle-based thing, so there was a MySQL database in the back and a Postgres and PHP and whatnot. So it wasn't just serving HTML pages; it was actually doing a lot of other stuff as well. So there were 6 devices in his thesis. There was the the XO1. I don't know if they did an XO1 5. There was the FitPC1, FitPC2. There was the solid logic device that OLPC itself was using in parts of Africa when they had that whole drive a few years ago. So that was, I think, a VIA processor at 1 gigahertz, somewhere in that range. Anyway, so he did all that stuff, and all the stuff is up online, all the data is there. So when this project came along, I said, okay, you know what, that methodology is there. We have all the materials needed to do this. Let's apply that same approach, but to these new devices. And so that's kind of what they did. And then you see this list here. You've got ease of use, power, updatability, web info, support, content, cost, and all that. Those things were added later because clearly, looking at the load profile is just one aspect of this. I mean, let's say they got a device from some vendor and they did all this stuff, and it turns out that nobody else can actually get that device. It's kind of meaningless. So we have to look at all of those things. So that's what they did to look across the board. Here are some numbers in terms of how they stacked up the different devices. So they've got Rachel, WiderNet, Library Box, Internet in a Box, Outernet, Library for All, Commonwealth of Learning, Open Learning Exchange, and in many cases, of course, they were not able to actually get the device, so then those scores became 0, and so that's how it sorted down to 3 devices eventually. This is the actual mechanics of it. So they use JMeter, which is a Java-based tool, runs on your laptop. They got, of course, all the stuff from Ben and his thesis, and they created essentially. So let me talk a little bit about how this works before we look at the devices. So you would have a laptop or a desktop with JMeter running, and then you would connect that to the target server. So let's say we were load testing a Raspberry Pi running Rachel. You would plug in the laptop or the desktop to the Rachel device, and that connection matters because if that connection is over Wi-Fi, as you start to load the server, your Wi-Fi may actually fluctuate, right? Because if you're in a place with lots of other radiation, your Wi-Fi will come and go. So for the purposes of a lot of this testing, we basically said, run the connection just as an Ethernet connection, so we know that you've got a link that's constant. At least over cable, we know that it's going to sit at a certain level. When Ben did his testing, he used a crossover cable, and then we were able to kind of look at the steady rate at which Ethernet would talk. So you sort of remove that out of the picture as a variable. And then on the JMeter side, it simulates the loading. So in JMeter, you would go and say, here's my server at this IP address, and I want you to fetch the opening page, and I want you to fetch this URL and this video, and so on. And then JMeter starts to do the simulated loading. Within JMeter, you then specify how many people will be accessing this and in what duration. So let's say we say, I want 100 people get to the opening page of Rachel in 60 seconds. So what that means is those 100 people will get to the opening page, but not in an instant in time, and not like in a linear fashion, but more of a distributed fashion. So you can actually apply a curve to it. You can apply a normal distribution type thing. So what would happen there is that some of the people would get to it very quickly, some of the people would get to it very late in that 60-second time frame, and some people would get to it, or a lot of the people actually would get to it somewhere in the middle. And so that's why you have that curve. And then it spits out numbers giving you the results as to whether all those 100 people got through, and what was the mean time, and what was the distribution, and all of that stuff. Which is interesting, but at this point, we just want to know when it fails. So one of the things we came up with was, fine, you begin with some arbitrary number, like 100, and if it flies, then you jump up to some other large number, so say 500, and if that flies, you jump up to 1,000, and if it fails, then you start to back off from the 1,000. And when it fails, it'll tell you what percentage of it failed. So then they would start to back off and say run 900, 800, and if one of those numbers passes, then you start to go back the other way. So you're sort of doing this ping pong thing until you get to a narrow window, and you find out at what point it approximately fails. So let's say, for argument's sake, it fails at 750. 750 people getting to Rachel in 60 seconds, and it starts to fail. Well, then for practical use, you should probably apply a 20% margin or something, 15-20%, and say, no, it's not going to be 750. Let's pull that back by 100 or 150, and say, hey, maybe 600 in the field, or 650 somewhere there, because you don't want to be sitting on the lip of that failure where they're not able to get it. So that was sort of the approach, and then you would get an idea. So it could be a number like 1,000 or 750 or 100, depending on the device. So they did that. The other important thing was the 60-second business. So let's say in this room, I tell everybody, pretend you were in a classroom and you all have textbooks, and I say, hey, everybody open page 83. And everybody then takes out their book and opens page 83. Well, that's not going to happen at the same time, right? So some people will get to it quickly. Some people will still have to take it out of their bag and open it. Some people will, have to be reminded 2 or 3 times to do so. And that's the distribution thing I'm talking about. But the 60-second part is also interesting, which is, in so many ways, we really don't know. Is that supposed to happen in 60 seconds, or 180 seconds, or 50 seconds? So in a sense, if you're at a deployment and the teacher says everybody's going to look at, the book about birds in the browse activity, how long does it take for that classroom to actually do that? And that's an important number because we don't know, honestly. We haven't gone back to look at that. There's some evidence. You can look up some research about that. So we saw numbers from 1.5 to 5 minutes for these kinds of activities. So 2 parts to it. 1, we really don't know much about that, but that's fine. And 2, it does play an important role because, if that window was 5 minutes, you could have a very low-end device that will still work because it's just occasional hits to the server in that 5-minute span. If that window is just 1 minute or 60 seconds, you've got an entire classroom jumping on it, you need a high-end device. So the demand on the server side is not a constant. It actually goes up and down. And that's not just for this. I mean, everybody who runs all these massive infrastructures out there, whether it is Google or Facebook or whoever, they all have to estimate this peaky demand stuff. And so that was the other challenge, which is whatever device we're looking at, how is that going to behave? Translating that into a real world scenario, which is now somebody here says, hey, I want to go do this at one of my schools. We can't look at the data and then say, let me go look for a device, because there's only so much that's available in the market. So it's almost like you look at the data, and then you look at a set of devices, and you pick the one that's closest to what will fulfill the needs of what you want, perhaps with a little margin, right? I mean, some margin for growth. So that's the methodology in terms of what they did. And they looked at some devices, so that's the worst possible ratio thing, and that's based on, well, they tested the original Raspberry Pi, not the second one. So that's something they haven't done. And these are some results that they have, and this is online, so I'm not going to go through these. Here's another interesting problem. I saw that SanDisk 32 gig thing there. The disk input output, the disk I/O of SD cards is very different than of a hard drive. Because SD cards, are typically used in phones and cameras. I said they're meant for, like you take pictures and it gets stored somewhere and it is written to the SD card slowly through that buffer. But when you're viewing it, you can read it very quickly. So quick reads, but relatively slow writes. Now, if your SD card is acting as your hard drive, that's a very different profile than a spinning drive that you may have, or some other kind of drive that is hybrid, so it does solid state and spinning. So that becomes a bottleneck, which also has to be accounted for, depending on what the usage is. They did library box. It's not very impressive in terms of what they do. I would probably not use it for any of our projects. It's a fun thing to do, but it's practically speaking, it's not very robust. This was interesting in that I think this was one of the most expensive solutions, and it failed the most in the testing. But then they also came back and they said a lot of it has to do with the fact that the hardware is great, the software side is just not tweaked, and Intel probably just gave it to somebody to build, so they don't build it themselves, and so it's not optimized. But it did fail a lot in terms of what it is supposed to do in the classroom. It's also very hard to work with because none of the server software that runs on the box is actually available to tweak with or anything. So unlike the Rachel device, which runs on Debian, I'm sure this runs with some Linux kernel, but we don't know the rest of it because they haven't made it available. So I don't know if they've switched, but I think what these guys got was not Ubuntu. It was probably some variant, but they did not have access to anything within it to actually tweak it. And then Intel has also partnered with somebody for the content, so it comes sort of prepackaged. And if you want to run your own, you can probably add a USB stick to it. That's the only port it has, it seems, for extra content. So.
It was just a recent, in the last 2 or 3 days, announcement that Rachel was distributing their content on that device.
That came after the thing was done, right?
So that's an interesting note.
True, and I don't know the details of like how that came about, but I know that, excuse me, Inveneo was looking at this device as a possible solution, and so they must have had some conversations there.
So the fact that Inveneo was doing this is the reason that the XS7 or an XSCE system wasn't tested.
Well, so XSCE or XS7 was not tested because they didn't have access to a device that, so they basically pared it down to,
That off the shelf.
yeah, can I call somebody and they can ship me a box that will test?
Because it's their commercial interest.
Well, that plus the whole set of things that they had in terms of the time, we didn't have enough time. So for instance, if somebody in our group had said, we'll ship you a box, then they could have tested it. But, more importantly, I think because we have all this access, we have all this material, if we had to test it, we can do it. It's not that difficult at all.
As far as the test of 60 people or 100 people essentially going to the main page, the way servers work is they cache pages.
Right.
So I've seen over and over again, the first person accesses a page is extremely slow, and the second person is pretty quick. So
Right.
if the teacher accesses the page and then tells the class to access the page, if you have enough memory,
Right.
they can be very fast.
Sure.
And I think this Raspberry Pi that you used with Rachel probably didn't have very much. I think it was 256 was the original Raspberry Pi.
That has another one.
Yeah, but this was, I know, but this one I think was still with the
Yeah.
256 or 5.
Yeah, so there are lots of those tweaks that you can do. So for instance, when Ben was testing the school server, XS07, he had done things by turning off Squid and then turning it back on to kind of see what difference. So there are lots of tweaks there. Disk input output is a big one. So if you, especially with SD cards, so just the kind of SD card you buy makes a difference. So those are definitely a lot of tweaks you can do. But unless you have, a baseline, it's kind of hard to figure out where to tweak. So methodology-wise, I would say the first thing to do would be, any kind of baseline system that you have, just out of the box, so to speak. Test it, and then see what the performance looks like. There are lots of numbers in JMeter. So for instance, the very first access taking longer, and then the cache, kicking in. You'll see that in the JMeter numbers. You'll see it in the table, the minimum, maximum, and which, the first access, the second access, and so on. And then based on that, you go back and fine tune it. So I think those are very useful numbers to look at.
Well, I think it's very valuable that you looked at the workload.
Mhm.
Most of the stuff that I've seen, nobody pays any attention to what the server workload is, so therefore that, you don't know anything.
There's another constraint to this, which is actually factored in, but we don't, look at it in this stuff with JMeter and all. We are actually looking at the power profile, right? I mean, we're looking at how much, what kind of electricity you have to run the device, because that in turn then determines which device you will use. So for instance, if you had good electricity, you could, use that quad core Xeon thing that I was talking about.
If you have a lot of money.
Yeah, well, money is not,
That's great.
yeah,
In that case, power is no problem either.
yeah, money is not there. We know a lot of people who have a lot of wealth, so for now we'll say that's not a problem. But electricity, is. So, but anyway, my point is that if electricity was not an issue, you could definitely get something where that's not a big constraint. But if you have to run off of a solar panel and a battery, you do have to worry about what kind of device to use. So that is a constraint, except that it doesn't show up in the testing. It shows up in the choice of the device. So you have electricity as a constraint. You have, of course, the usage profile, how the server is used. And then, of course, you have the size of the classroom, so to speak, or people who actually get it. Yeah. Those are the three main constraints.
So from my perspective, the networking was a big part of the issue. You basically you sidestep that.
Right, we did.
And, another one is typically, at least when I was involved in this business, our goal was to find out what was the limiting constraint that determined the performance. Was it memory? Was it the processor speed? Was it I/O speed within the box? Was it I/O speed in the network?
Yeah.
And those kind of things, or processing time to respond like a search.
Right. So there are a couple more things that in this we did it, but it's not part of the report. So one of the things these guys did was there is a utility you can run inside the server. So JMeter comes from the outside, it's a little server. There's a utility you can run inside the server that actually logs all of those things. So it logs just input output, it will log memory usage, CPU usage, and all those things. And so that is available then as a profile as well, which you can actually then correlate and see, well, when I threw 1,200 people on this, where did it fail? So going back to Ben's thesis, when we, I was very insistent that he should test the XO1 as a school server because I just wanted to see, say how low can you go, right? And so it was an XO1 running the school server. It had an external USB drive piggyback, like, literally piggyback because we had to use double-sided tape and stick it on the back of the XO. And when we looked at the numbers from within the server, the biggest failure was the SD card because the input output just kills it. And then you can actually see the graph of that data. It's all very spiky because the SD card simply could not deal with it. Whereas for the other boxes, it wasn't an issue, it was something else. So that's the other thing that we've done is to sort of look from the inside and see, because the things you suggested, like cache and those things, to tweak that, you need that data.
In the XO1, there's not much chance to catch.
Just as a side comment, because this Noonan thing that does the internal analysis of all of the shortcomings of the server, we've included that in the XSCE, so it's just part of the thing that gets loaded if you choose it.
Yeah, so Munin will give you that profile, but what we found was that when we were doing the testing, Munin's, or at least I guess the way we were able to configure it, the resolution that Munin has in terms of what it gives you is not fine enough to actually get good results for this kind of testing. So we used, I'm trying to remember the name of the utility that we used for this. It'll come to me. But there we were able to get a very fine resolution of this data for what's happening inside the box, and of course JMeter gives you what's happening outside the box, put the two together. And then there are other things that can be done for sure in terms of just tuning the system and trying to figure out, again, I think this time window is very important. A lot of the tests we did when Ben was working on this was very aggressive. We began with 60 seconds. I'm like, I can't think of any scenario where all the kids in the room will actually get to the page in a minute. You have the teachers in the room smiling. You know what I'm talking about. So that's very important to know if it's going to be 5 minutes, 3 minutes, 1 minute, or what. So that's what the project is in a half-hour nutshell. And from here on, it's like, well, what should we do with this? What are the things we can test? What else should we do? The scripts are available. JMeter is, of course, open source. You can download that. You can pull the profile straight into JMeter with all the stuff, make minor edits, and test away. So what should we do?
Have you tested the video streaming?
There is a video access.
Caching and stuff like that, or the time in which people access it, like the 60 seconds don't matter anymore because you stream over multiple minutes and your load time will accumulate.
So, none of these things were actually set up to do real streaming. In a sense, they're not using a streaming protocol. It's still just a video file being served over the web, HTTP, and it's just that your browser has to be smart enough to start playing it as it comes in, as opposed to downloading the whole thing in. So it's not like it is.
Small quibble here. What I do is I download to the journal any media file, except for real short MP3s, because in general the kids are not going to have faster time to look at the videos. So if they go away from the classroom, they don't have access to school servers, so there's no opportunity to stream. So they really need to have it local. And then they need to erase that one to make room for another at some future point. So I think that measurement of measuring the download time is appropriate.
So that download would still be an HTTP download as opposed to streaming.
Which is why the network becomes an issue,
Yeah.
because if you've got 100 kids going into the school server simultaneously downloading a 2 megabyte file, that gets into some real networking issues, I think.
Simulating the network load was also something that we looked at, but there are a couple of issues there. So one is the Wi-Fi link, like I said, it'll behave in, well, it's still predictable, but very hard to control. So Inveneo does have a feature where they can put stuff in a box, and it keeps all the radiation inside. And so you don't have external stuff coming in, and you could actually test it. But that would not be a real world scenario because you would not be living inside that box, right? But you would have, some numbers.
Many of our deployments, of course, don't have access to the internet, which implies that you don't have a very active radio wave.
Well, yeah, so maybe in that spectrum, if it's cleaner, but again, that's a variable. We don't know, what you may or may not have. So that was one issue, but Inveneo does have the box to actually test this. So if there was some interest, you could go back to them and say, hey, we'll run the test again, but this time, we'll put it inside the box.
Our deployments are probably not their commercial interests. So.
No, actually, a lot of the stuff that they do is in places like what we've done. So
They deployed internet in a box recently, right?
Mhm. Well, Rachel, I think they did internet in the box as well.
And aware.
In Micronesia, so mostly Pacific Islands, Micronesia, lots of places where it's all still solar and
Those should be pretty low radio
Um,
areas.
Yeah, but if you have like 100 clients connecting to a school server, you have a lot of radio activity.
Well, but
Everybody is using Wi-Fi.
but at least it's yours.
Yeah, but there's still interference. Like connecting 10 clients to Wi-Fi access point, you have a lot of interference.
And that's what I'm saying. And looking at the network side is pretty important to this thing.
Yeah.
Because and another one is to set a range. I used to think that maybe a school server should handle 500 exos as a max, but I think that number is probably quite a bit lower than that.
yeah. So that was my second point, which is that's another constraint, and it's interesting in that. So and Alex is trying to do this, and we've tried to do this in our meetings. So once you set up, let's say, a Rachel device with a Wi-Fi dongle, how many exos can get to it before it stops giving you connections, right? And that's again not a variable because that number is set in a particular line item in the kernel module. So when you plug in the Wi-Fi dongle, whatever hardware is inside that dongle will activate a particular driver. And when that driver was compiled, there is a line item for number of stations, which is set. And so if that number is 12, you will not get more than 12 unless you redo the driver, right? So you can go back and recompile the driver and say 64 and hope for the best.
Well, what all in Polish can do is they get from a typical TP-Link commercial off the shelf about 15 connections.
Mm-hmm.
But with using OpenWRT, they've been able to get regularly 30. And that's the classroom size, that's their target model.
Right.
So that's essentially what they do is one router per classroom.
Right. So there's so that solution has to be addressed at the radio level, so physical there or data link there, as opposed to the stuff that we've been doing, which is all at the application there. And there are some tools that can do network simulation, and they're quite good. And it's one of those things where you would actually not have to involve any hardware, as long as you sort of knew what the traffic pattern was like, and you could simulate that and say, here's my link, it's a Wi-Fi link, here's the distance, and this is the traffic, and this is what we get. And we can actually look at the numbers and see what those are like. But yeah, I agree with you that the network part is definitely a part of the solution. And you can do all the stuff on the server, but if the network doesn't hold up, it doesn't work.
In the context of the business side, education side, obviously there's marginal cost trade-off here. If a second school server costs an additional $400, at what point does that become practical as the number of XOs go up, which are at $200 a piece, essentially.
Yeah.
And the same thing, one recommendation, I think it was Jerry Bonham made it, or maybe Anish, but anyway, that what we do is we set up the router to control a local network and then provide a gateway through to the school server. So all of the traffic in the classroom stays in the classroom. And the next classroom, all of that traffic basically stays there unless they're actually going to the school server.
Right.
And that might, we don't have enough experience, but that might actually be a good solution from a networking point of view in a school.
The second
Deserves to be tried.
So if we, so these are the things we have access to, which is the JMeter setup, the scripts, essentially a way for us to load test. Beyond, of course, what these guys did for the internship, anything else that we should look at? If you have configurations we can test or we should look at, that's something we can take on as a project down the road, in terms of, looking at things.
Well, I went to this conference in Raleigh, and there was one of the booths was a package called Grafana, and this is a package for basically graphing time series, but their example was graphing server statistics.
Okay.
And so they had various graphs of the inner time between requests, the time, the relative time it took to process different requests, the amount of data transferred as a result of a request. So they measured a lot of the important statistics, and then they had dynamic graphs, which I think would interest the kids as well. If we had some way to really display what's actually going on in the system so they can see what they're doing in real time. But
So would Munin do something like that?
well, you said you had another package that probably gave better resolution, and this thing is designed to show time series down to very small increments. I think they were sub-millisecond.
Do we have a sense of what people are using in the field for servers now? Have we sort of come to a subset of machines, or are we still
The
just sort of
only poll is distributed about 250 MSI
MSI?
Atom-based servers.
Okay.
In Rwanda, they distributed 200 servers, but their ATX boxes
Okay.
with, I don't know, some massive, not a Xeon, but probably i7 or something of the sort.
Are those running at the school?
Yeah.
Okay.
But it's strange, but nonetheless. But my sense has been, from my experience in the professional world, was for the servers, we're doing file delivery or web service. And file delivery and web service are not very CPU intensive. They're very memory intensive. So luckily, the economics are going in our direction because memory is becoming very cheap. So having an 8 gigabyte store is not difficult at all.
Right.
And of course, the terabyte drives are down to ridiculous numbers. So servers are really not very expensive at that level, but you don't have a lot of processor speed. So for example, in Internet in a Box, where they do searches like on Gutenberg, those are very, very slow because they're using a server processor
CPU. Okay.
instead of doing it locally. I think having predefined indexes of URLs so that the user clicks on that book, and that's just the URL, is much more back to the web service area, and I think that's where our sweet spot's going to try to be, avoiding the searches. The searches where the computing is doing on the server side. The searches on the client side, that processing on the client side is probably okay.
Right. And nobody's using something like a Raspberry Pi for these things, right?
Yeah,
Other than the Rachel stuff.
XSC is being distributed to some degree on that.
So is it?
Raspberry Pi.
We're going to test it. So.
I don't know of anybody that has actually installed XSC on a Pi.
But performance-wise, the Pi should be very
I'm hoping
comparable to the XO.
Yeah.
Yeah, so Andy's got Pydora, right?
Yeah. So this is supposed to be set up on Fedora. The links currently don't work, but we can. The Haskell script should be able to execute on as it comes on Rachel.
So were you able to install?
I'm just downloading it.
Oh, okay. All right. But that's one big challenge, which is so much of the Raspberry Pi side of things are Debian based.
Yeah.
And then all the stuff that we've done is Fedora based. It's hard to sort of.
Yeah. With the Haskell scripts in theory, they should all work. Okay. So we'll see.
But in theory, they should also work on Debian, right?
Yeah.
Well, there aren't a lot of packages. There are packages missing in Debian.
Yeah. And the Red Hat acquired Ansible, is it? Or there was something recent that they, yeah, that's going to be part of
Ansible is now back part of Fedora,
Yeah, it's part
or
of
Red Hat.
Red Hat. It's part of that empire. So
Yeah, so Greg Königsberg is now back as an employee. Full circle.
Yeah, so I think, we have like 2 or 3 candidates, in terms of devices, we could definitely test those. Um, We have more students here who love to work on stuff like this. If you guys have an opportunity, we can learn those things. I think what we would need though would be those candidates, which is, not the physical device, but, what specification, what should we be looking at?
Well, this is another thing about measuring devices, because it's, in the manufacturing world these days, it's becoming device of the week. But Intel has come out with their new processor generation called Skylake, which is based on their 15 nanometer technology. I think that for the next few years is going to be where we're at. But those devices are not yet available in the marketplace. I'm guessing probably spring.
They're covering their Arduino now, right? So they're making an Arduino add-on based on those.
But this is the way Intel works, is they'll do the engineering so they can get people to use the chip.
Yeah.
And, but there'll be a new refresh with that chipset probably within the next 6 months, maybe sooner. And I went to a conference or IFA meeting in Berlin, which is their equivalent of the consumer show. And MSI and SOTAC and Shuttle all assured me they had them in the works, that the Skylake machines were coming out imminently. Every time they do that, I wait 6 months, because that's about how long it takes to get from the show to the floor to, bring them by. But right now, I think the one, George, the Nuke 3401, is the one we're using. That's the one, the Nuke you're using, right? The i3, which is, I think, 3401 is the magic Nuke. So that would be a good candidate.
And how much are those devices?
410 or something like that, and you get a disk.
That's 410 equipped with a hard drive and memory. You buy them bare bones and then you circuit. And that's a little more pricey. The 2830 box is about 110, 120, something like that. It's not quite as powerful a processor, but
And you get you up to 250 if you have a hard disk and memory.
yeah.
The problem we ran into with that one is it doesn't have portable storage.
And my guy, I didn't hear.
Is it, so the advantage of the one George is using, I can't remember the number, is it has a wider range of voltage, it looks like, it goes up 12 to 19.
The newer technology is much lower
The
power.
newer one,
I mean,
but it
the
accepts
memory right now is running at about a volt, okay?
yeah, but it accepts a lower range, so you can't.
Yeah, so you can run it directly off the battery, car battery.
Yeah.
And you don't need to put in an inverter, which we had to do before, because the hardware for that was taken off of laptops, and the laptops needed 19 volts to charge the battery, even though there's no battery there, we ended up with that hardware. So I think you found that the newer ones, you can get by with 12 directly, like this iPhone.
The 2830, which is, I think, the new Bay Trail thing, doesn't run with 11.5
But it's
volts.
still using the laptop power supply.
So that's a real conflict, right?
The 2830 is I'm saying, within a few months, we're gonna have a new Skylake
But
level. That's a much lower power drain.
And so we'll have to wait and see whether they have a 11 to 19 or 11 to 15 at least voltage input range, because that's what we need to resolve. Right.
Because I'd be willing to pay more for a device that I don't need to buy an inverter for.
My economic sense of this has been, if we can keep the school server price less than the cost of 2 Exos, that's probably okay. So it's under $400, that should be reasonable for deployment of 10 or 15 to more Exos. Now, some of these Atoms deployments are like 2 Exos, and now it becomes questionable whether you want to put $400 into a server.
So I have a question.
Yeah.
So far, the negatives of the Raspberry Pi solution are the SD performance and the fact that it's predominantly based on Raspbian, correct? Are those the two drawbacks of the
Well, there's
Raspberry Pi?
also no Fedora, so you could
Right,
install
so
Fedora. So
That's the next evolution, but
Yeah,
that seems to be the bottleneck.
I don't think that the Hydora or the Raspbian is an issue. Right? We've been running on the Fedora.
So maybe just the disk performance, the SD performance?
So yeah, so
why would that be a bottleneck when you're mainly reading?
Well, if you're caching, you're also writing.
Yeah,
Because
well,
you're
you
limited
could
by the
put
amount of
the
memory.
cache on
so there's caching, and then some of the stuff, if it's running a database in the back, then
yeah.
And the other big problem is that you're totally limited in memory because it's built into the motherboard.
And
You know,
also, there's a,
these guys have got about 8 gigabytes of memory, which is big, a bit bigger than 500 megabytes. When you're talking about servers,
Right.
servers just need memory. That's the way the servers
and
are.
SD cards wear off, so there's.
Right.
But if you had adequate caching, they'd wear out a hell of a lot slower because you wouldn't have to go back to them so often.
Yeah.
But when you don't have very limited memory, then you have to keep crashing against the SD card.
Have you guys the documentation for the recommended specs that you're currently using? Like, I mean, one that
Yeah, essentially you want a system atom-based or later Bay Trail or something like this. I like Intel processing simply because it's worth Intel, but that has nothing to do with it. Really, the main thing is the software is there. If you go on the ARM side, then you're a little bit iffy as to whether or not you can find the software you need. CentOS for the software base, simply because CentOS is designed to be more stable
you use it for
than
the
Fedora.
network.
Yeah, so I would much prefer CentOS. As far as the rest of it, as much memory as you can afford, but 8 gigabytes is a good number, because that's not very expensive these days. And these things typically have 2 slots for memory, so you could go to 16, I suppose, please. But 8 is a good number. And then a terabyte hard, a 2.5-inch hard drive, that notebook drive. And if we get more content than that, then we just go to 1.5.
Yeah, what's the manufacturer of that?
These are Intel new, but there are other manufacturers. Zotac makes them, MSI, Shovel,
And you see it,
Gigabyte.
Yeah.
There's a variety. These machines are typically designed for the home theater market.
So I just put up some graphs from the XO1 as a school server. And you can see that's 150 threads, that's the CPU, you know, jumping all over the place. Memory was actually, you know, not much going on. That's the disk I/O, and you can see how like, jagged it is. So SD cards, I mean, that's definitely a thing. If you're writing back to it, then it's a challenge. Now, I guess one way to address that with something like the Raspberry Pi would be that you would keep the SD card in a read-only type mode,
Yeah,
and then you would have a
spinning disk.
spinning disk that does all the. Many years ago, we used to. There was a project where we used Debian to run an access point. This was the early days of Wi-Fi, and what they would do is they would actually boot up the whole thing, but at boot up time they would take a portion of the RAM and partition it as a temporary partition, and all the /var, which is all the logs, would get written to that.
Yeah.
So that's part of the memory. And then the rest of it would just basically be in a read-only state. So the entire was sat in a read-only state, and the logs, which is what it gets written to, sat in the memory.
And then once a day you dump them.
Well, so there are a couple of things. One, they didn't care for the logs. They're like, you know, we don't care. The reason this setup happened was because when you put the power on these things, you would corrupt the drive.
Yeah.
This way, because it was read only and it was a compact flash device, it wouldn't matter. It would just stay the way it was. I mean, things have changed a lot since those days. But so that was an approach where, you know, all the read-write bits would go to some place where it's faster. So that would be one solution, is to actually do /var or something.
Yeah.
Under the spinning drive, and then you keep the rest of it on the SD card.
So we'd have to test what the I/O speed and.
I know, yeah. So again, we sort of go back to that, which is let's see where the bottlenecks are.
But it would be interesting to find out because it would be very affordable setup, like you could put like you're doing, like, and very low power. Like,
So yeah, that would be interesting. Well, I guess once you get this thing set up, the Fedora thing,
Yeah.
you can maybe run it through a profile and see. Any other interesting things about the server people are working on?
You're talking about digital library, which is the way I would have interpreted that going in is how do we in fact get information to put on the school server that in the form of a library.
That's a whole different challenge. Right?
It's the challenge in a sense. I mean, obviously we have to deliver it after we get it, but we need to get it first. So right now, that's one of the things I'm trying to work on is to come up with a library scheme where the local school deployment can add accessions to the library and expand the definition of library beyond ebooks to include, audio files, video files, and even sugar activities. But in other words, the accession could be whatever, any kind of a file by a line type. And then, so the user should be able to upload that file and then create index to it so that people can click on buttons and get to whatever the item is. Like, right now I've got it ordered that the category, there's topics is the top level, and then under topics you have collections, and under collections you have the actual items that are in your library. So you can make an arbitrary collection. So for example, one of the things that Zora wants to do is to have the students output in the library adjacent to the Gutenberg or whatever other library materials you have, so the kids can see their stuff at a level. And that can be done because you just make a collection, put what they consider to be related things together. That's been one of the problems with acoustical library is that once you take the slice, you're dead. You can't add anything to it. You can't adjust it because all of the librarian support is on their online site.
Right, so
All they're doing is taking a snapshot.
Yeah.
So we really need a librarian capability. I think.
We have a session in the afternoon. I'm hoping that will address some of that. These guys came a couple of months ago talking about an approach where you have, different sources of information and different formats, and there's a way to actually pull that together. So let's see if they have something interesting about that in the afternoon. Any new features in the XSCE that you want to maybe comment on?
Well, I was going to show them this afternoon, but we have the ability to, we have a new graphical user interface which lets you choose keywicks sources and install them locally.
Oh, nice.
So,
It's
That's
pretty
what
cool.
we're from.
Yeah. All right. Well,
so and
We'll wait for
also,
that.
as you know, the topic bar has been upgraded so that the students can add their own
Right.
books and notations. So there's a lot of stuff in that CD that's new.
Okay, great. So I guess we'll wait for your session to learn about those things. All right, I'm gonna stop the Hangout thing here so we can wrap this up.